All right, we're going live. Anyone there? Can you see me? Let's see. Okay, going live. Okay, so are there any? So what I'd like to do today, first, I did post some more practice stuff for y'all on Blackboard. So there's more gas review stuff, solution stoic, and a molarity practice quiz. So it's nothing new, but just more practice. So I suggest you try these problems. There's not that many. They're all one-sided worksheets. I'll post the keys tomorrow, and we can go over any questions you have on Friday in the live stream. If you have any questions about these worksheets, we can post them then. But right now, so go ahead and make sure you work on those, all right? But let's see if you have any questions on the practice test that you have. We've only got two people here right now, so feel free to say hi in the chat, or just let me know if you have any questions. Let's go over the practice test. So the Unit 6 practice test, I posted the key yesterday. You might not have that many questions, and so this might be a short stream today. But I posted the key. If you haven't yet checked out the key, then you might want to do that. I want to go over any questions you have. I think most of it was pretty self-explanatory, but if you have questions or any ones you want more of an explanation on, please ask either in the chat or send me an email, and we will go over any questions on that practice test. Okay, Jalen. Let's see. Okay, so did you have trouble with the answer key on Blackboard? Here, what I'm going to do right now, I will email it to everybody through Google Classroom, that answer key. Yeah, for some reason, some of the PDFs that I've scanned, they scan fine on the computer, but then when I post them on Blackboard, for some reason, you can only see the first page, or I have no idea why that is. But let me go ahead and I will send the PDF to you. And so I think maybe this way you'll be able to open it on your computer and see the whole thing. Let's see if that works. Okay. I just sent it, so please check. Please check your Google email. For the key. Maybe I think what I'm going to end up doing is, as we get further into over the next couple days, I'm going to be updating not just Blackboard, but also the Google Classroom. And so I'll be posting stuff on Google Classroom as well. So I think you'll be able to see the PDFs better there. Also, I'll be posting all the live stream videos that we've done so far, post them on the Google Classroom as well. So you have access to them there. You don't have to go to the YouTube channel or whatever. But that'll be kind of I'll have all that set up by the time we can have some mandatory work. But right now everything's optional. I gotta make sure you understand it's all optional. If you want to stay you know, afloat, you know, stay on top of everything, or, you know, do you want to get kind of smacked in the face in 3 weeks when we come back and I, you know, make things mandatory? You know, that's the way it's kind of going to be. All right. So hopefully that worked. Jalen, if you hear this, could you send me an email and let me know if now you can see the whole key now that I emailed it to you? I apologize that you weren't able to see it before, the whole thing beforehand. But let's go over. Okay, so we're going to go over questions 22 and 23 right now on the practice test. So let's check those out. 22 and 23. Okay. So a sample of nitrogen gas is collected over water at 20 degrees Celsius. The total pressure of the gas collected is found to be 850 millimeters of mercury. What is the partial pressure of the nitrogen gas collected? Okay, so to answer this question, so let's just understand yeah, everything that we've done so far, Aaron, is on Blackboard. And every mandatory thing, all of it's optional. So when we are allowed to make things mandatory and stuff, we're going to be doing all this stuff kind of over again. And the people that have stayed on top of it will just kind of, you know, they've already done it, so they're in good shape. And then so for the people that haven't been kind of following along with their studies during this time, they'll, you know, be able to catch up. So no worries. But everything's on Blackboard. And right now, if you go to the YouTube channel that these live streams are on, you can get the other live streams. They're posted on YouTube. But eventually, I'll have those videos posted on Google Classroom too, so you could go back and catch up and see the previous live streams as well. All right. So to answer this question, I got to go back to some notes that I gave you at the start of Unit 6. And so remember, like, so you got, where is it? All right, okay. So you got these right at the beginning of Unit 6. I told you to read the notes, but, you know, you might not have completely understood it. So first, let's look at these notes. Okay, so let's understand when you're collecting a gas over water. So it's this kind of setup right here. Okay, so you have a tube where you're producing a gas in a reaction over here. So remember, we did that reaction before, right? We did when we did the chemical reactions lab, we did zinc and HCl, and the H2 gas bubbled out of solution, and then we made that zip sound when we tested for the hydrogen gas. Well, when you collect a gas over water, the gas that's in so what's happening is the reaction is producing H2 gas. The H2 gas is bubbling through this tube. It's going through here and it's going up, and we're collecting it here. Okay, and it's being collected over water. Okay, well, understand that water molecules, even at just room temperature, will vaporize a little bit. So what does that mean? It means the gas that's in here, right here, is the gas that I'm collecting in this case, in this notes case, the hydrogen gas, but it's also the water gas particles too from the water that vaporized. Okay. Well, the total pressure of the gas of whatever the total pressure of the gas in that compartment right here is equal to the pressure of the hydrogen gas I'm collecting, but it's also plus the water gas that vaporized, right? That's the total pressure. So if I measure the total pressure, that's not going to give me the pressure of just hydrogen in this case. It's going to give me the pressure of hydrogen and water. So if I want just the pressure of hydrogen, then, or whatever gas I'm collecting over water, I have to subtract the pressure of water to get the pressure of the gas that remains, right? So what we're saying is here, so total pressure so if you collect a gas over water, we're saying the total pressure of the gas equals the pressure of the gas you're collecting, but it also equals the pressure of water at that temperature as well. Okay, well, water has a different vapor pressure at different temperatures. The hotter the water is, the more particles will vaporize, the higher the vapor pressure. So if you're asked a question where you're trying to find the pressure of just a gas above water, but you're given the total pressure, you also have to be given the vapor pressure of water at whatever temperature you're talking about. It's not something you have to memorize. It'll be given to you. Okay? So if we go back to this question here, number 22, whenever you're said you're collecting a gas over water, think like it's a long, usually the question's kind of a long setup, but it's the easiest question you can answer. It's Dalton's law, and it's simple. It's total pressure equals the sum of the partial pressures. So all you have to do is take the total pressure given, 850 millimeters of mercury, and subtract the vapor pressure of water given, and that gives you the pressure of the other gas that remains. Okay? So that's all you have to do there. All right? Okay, and then number 23. Okay, so number 23 is an ideal gas law question. Okay, it says how many grams of oxygen gas will be found in an oxygen tank that has a volume of 25 liters, a pressure of 50.5 atmospheres, and the temperature is 25 degrees Celsius. Okay, so this isn't like a gas law question where it's like initial pressure, initial volume, final volume. It's not about Boyle's law or Charles' law or anything like that. When you're just here's the pressure, the volume, and the temperature conditions, you know, how much gas is there? That's an ideal gas law question. Okay, so the first thing I have to do is solve for moles. Okay, so the first thing I have to do is solve for moles. So if I'm using the ideal gas law, it's PV equals nRT. N is moles of gas. R is the ideal gas law constant. Notice all the units for the ideal gas law constant are just telling you what the other units have to be. My unit of pressure has to be atmospheres. My unit of volume has to be liters. My unit of amount of gas is moles. And my unit of temperature has to be Kelvin. Okay? So we would do 50.5 times 25 liters. That's pressure times volume, right? So N equals PV over RT. The temperature is 298, not 25, right? It has to be the Kelvin scale. And then times the R value. So that comes out to be 51.6 moles of oxygen. But it asks for mass of oxygen, so now what do? We take 51.6 and we multiply it by 32, which is the molar mass of oxygen, and that's how we get our 1650. Okay? So let me know, does that answer your questions? June, did that answer your questions for 22 and 23? Or do you still have more questions about those problems? Okay. And also, just are there any other questions with the any other problems on the practice test you'd like to go over? Thanks. Okay, good. Good. All right, other questions? If you have them, you know, don't hesitate to ask, guys. We will, no, I'll answer your questions. Okay. So again, questions on the unit test or the practice test, and then if we don't have any more questions about that, are there any other questions just in general? Any questions at all with what's going on? I mean, I can't really answer that many, like I don't have the answers, but I know that we're getting together in content teams and stuff like to figure out what we're going to do about like grades and all that stuff. But again, officially, right now, we've been told that we really can't assign anything yet. That might change, but right now we've kind of been told not to officially assign anything until after spring break. So, you know, right now it's just kind of, hey, here's some extra practice. Let's try to keep chemistry fresh. Okay. Questions, concerns, anything on the test? Anything else? Any other chemistry questions you might have? Again, feel free to email me the questions if you have them, or post them in the chat. We're 19 and 20. Okay, 19 and 20. Okay, so for 19, same temperature. Remember, as soon as you see same temperature, you should be thinking same average kinetic energy. You say, okay, same average kinetic energy. And same average kinetic energy means lighter particles are faster, heavier particles are slower. That's it right there. Same temperature, lighter particles faster, heavier particles slower. And it doesn't matter if we're talking about effusion, which is escaping, gas particles escaping through a tiny hole, or if we're talking about diffusion, which is just the gas spreading out and mixing with other gases in the container. Okay, the faster particles will do both the fastest, right? The faster they're moving, the more they're going to spread out. The faster they're moving, the better the chance they have to escape. It's not about the size of the particle, it's about how fast they're moving and how many opportunities they get out. Remember, for an ideal gas, we assume that volume particle is zero for any gas. We ignore particle volume. Okay, so it's not the size of the particle, it's how fast it's moving. How many opportunities does it have to escape? So same temperature just means the lighter particles will move the fastest. That means they'll have the fastest rate of effusion. And so all you have to do is calculate the molar masses of all these, and that's what these are. Like, so oxygen's 32, nitrogen's 28, argon's 40, and methane is 16. So because methane's the lightest gas, it is going to escape through a tiny hole faster than any other gases because it's moving the fastest. Okay. And then 20, which best explains why pressure of a gas inside a rigid container will increase as the temperature increases. Okay. So rigid container means you have a fixed volume. Okay. So that means the space that the gas occupies doesn't change. Okay. So increased temperature means particles move faster. If particles move faster, they collide more often, and they collide with the container more often with greater force. And that's what pressure is. It's force of the collisions with the side of the container per unit of area. And you're going to have more force with more collisions overall as the particles move faster in the same amount of space. And so that's why B would be the right answer there. The particles move faster, so they collide more often and with more energy with the walls of the container. Okay. Was it 19 and 20, or did I get that wrong? Okay. So let me know if that works out for you, Mary. And if not, does that make sense? Hopefully that answers those questions for you. Okay, good questions. Again, all this stuff, the molarity stuff's kind of new. It was new. I'd say kind of new because we know what moles are and we know what volume is. So molarities, I'm walking the tightrope there. I'm saying molarity is not new content, even though it kind of is. Okay. All right, good. Any other questions? So again, if you feel good about the gas stuff, then you might want to focus on the molarity practice quiz that I assigned and the solution stoichiometry practice if you want to give that a shot as well. But the gas review questions, they're more about the kinetic molecular theory of gases versus using gas laws. So you might want to give that a try. They're not long worksheets. They won't take you that long. And if you don't know how to do it, then just wait until I post the key tomorrow and see if you get that. And then if not, then show up on Friday and we'll have another Q&A session for those worksheets. Okay. I'm going to post the keys on Blackboard, but I also will send them out in Google Classroom so you can have copies of them in your email too. Just again, I don't know why we're getting you know, the PDF files, they're fine electronically until you post them on Blackboard, and then for some reason people are having trouble opening them from Blackboard. Okay. Any other questions from the practice test or anything else? Any other questions? Like questions about the class, questions about chemistry in general? You know, anything. Or just the test. Okay. All right. So I guess we'll just end it there. Again, don't hesitate to email me questions. We don't have to be on a live stream for you to ask questions. Send an email if you have them. I will respond quickly. I got, trying to, do some improvements around the house and stuff like that, but you can't really do much. You know, so I will respond to you if you just email me as well if you have questions. Okay, so look for some announcements. I know I'm meeting with the rest of the chemistry teachers tomorrow, and so we're going to have kind of a plan of, I don't know, we'll see. We still haven't been told like how the third quarter and the fourth quarter are going to work. They're still negotiating. Some of the school board members had said something about extending the school year, so I know that doesn't sound appealing, but we'll see. I don't know. Everything's just kind of rumors, and we're not going to be told until the decision is made. So just, keep checking and try to stay on top of things. I might start posting some review material. I don't know if I'm going to do any more new stuff. Like we did molarity and kind of solution stoic a little bit, but part of me wants to hold back until I feel. But we might do some heat stuff because I know we talked about delta H and stuff before the quarantine and stuff. So I might do some thermo calculations with you, some that kind of thing, or we might go back and start reviewing some of the units. But I don't know if Mary's still here, but congratulations, you don't have to take the SOL because if you pass the class, you get a verified credit. They're canceling the SOL, so that's kind of a cool thing. So no one has to worry about the SOL this year. So I know I think I had 7 students that needed to take the SOL because they either moved here or they needed a verified credit or something like that. And so you don't have to take it. As long as you pass the class, you'll get your verified credit. So that's good to know. All right. So anyway, have a great day. Thanks for joining me. And again, if you have other questions, please don't hesitate to ask. And if you know some other of your chemistry classmates that haven't been joining us on the live stream, you might, I don't know if I feel like they should know about it, but I guess no one's really obligated to check Blackboard or Google Classroom right now until after spring break. So, but you might want to give them a heads up, like, hey, they're still doing some stuff. But anyway, I will post the key tomorrow, and I will see you again on Friday if you have questions. Okay? All right. Have a great day.